As we look out across the industry and break down the digital roadmap and like what's working and what commonalities are we seeing, we've identified, six key patterns that keep coming up as factors are having success with adopting digitization and thinking about what makes sense for their applications. The first one is that factors are adopting a streaming architecture. Streaming means that data is flowing from system A to system B or from machines into a variety of systems as is happening in real time, data flowing from place to place, not sitting idle in a static database. The second thing we see is that the data that's being streamed is getting more complex and more complete. Whereas in the past, a factory may have collected just a simple KPI from a machine or an individual PLC tag or like one or two data fields from an inspection machine, like just a pass or a fail. Now, increasingly, they're trying to collect and represent and pass through their systems, the entire rich event of what happened on that machine, because the downstream consumers of that data need that richness and need that nuance in order to make their decisions and power their applications. One of these applications, which is happening increasingly in the factory, are advanced shop floor control use cases. Whereas in the past, automation meant, PLC level automation at the SCADA level. Machine A talking to conveyor belt B and exchanging a conveyor width, or sending a recipe from two machines to each other so they can agree on the name of a product, for example. Now we're seeing things like AI assist on an inspection result, or stopping the line if the yield is predicted to be too low, not measured to be too low, but predicted to be too low in advance. These sorts of advanced contextual use cases, they need a higher level of data, and so they're being pulled out of the SCADA layer and put up sort of next to the MES as the advanced shop floor control. And advanced shop floor control needs these rich events. So as the use cases are increasing, as the volume data is increasing, and the complexity of the data is increasing, the factors are finding that the venerable MS SQL database is not enough anymore to handle all of their needs. And there's a specialization happening. So now there are time series databases to power dashboards and visualizations. There's separate event-based databases or data warehouses designed to capture traceability data or power ML or AI applications and data science applications. These exist in parallel to dedicated alerting databases, whose job is to be able to comb through all this information and alert you when specific conditions are happening, like predictive quality conditions, for example. And as this data now is collected into these larger databases and is for the first time sort of easily accessible off the shop floor, a bunch of other enterprise systems, which previously never had access or visibility into what was really happening on the shop floor, are realizing that actually is at the core of what they do. So use cases like global OEE, like emissions reporting, like advanced material optimization across the enterprise in this era of supply chain disruption. These use cases are now realizing that actually they need to know what's going on in the machines, where is scrap happening, exactly why, and in what cases. And so all of this is coming together into what we're seeing as a common reference architecture for how data is flowing through the factory, where it's going, what are the key use cases, and what are the important pieces that need to be in place for this to work in the factory. And we're seeing a lot of commonality in this across different factories of people adopting similar architectures, making similar decisions, and having similar needs, and it working in a similar way.